I'm really excited to welcome Austin Fatheree up to the stage. Austin is the CTO of Origyn, an incredibly big part of the ecosystem.
First of all, I want to thank Code and State, specifically Isaac, who I know poured his heart and soul into this event, and it's really amazing. It's so awesome to be here and to see all these folks that I've seen in little Zoom boxes and little Twitter circles, to see everybody in person. It's great to finally be here and meet everyone. So today I want to talk about what would an IC maximalist world look like, and really ask this question: what if the IC wins? I feel like in our community, it's been a rough 2 years, and in a lot of ways we've sort of turned in on each other, and we've lost some friends along the way, and it's not always optimistic, and we're like looking for plan Bs and Cs. But I want us to dream a little bit. Winning is still on the table. Having the IC, and this is my definition of what I think IC maximalism is. This is still achievable, and it's still on the table, and I just want to dream a little bit with everybody. My version of IC maximalism is a future where the IC plays a central role in the digital landscape and is used ubiquitously by people that don't even know they're using it. And I think it's a long road. We're still at the beginning, but it is certainly achievable. And I want to start this talk by saying that these are what I called holos, which are highly opinionated and lightly held opinions. And I'm doing this in part because since we are all here in person and we can see each other in the eyes, that builds trust between humans. It's really hard to have trust when you can't look somebody in the eyes and you haven't been in the same personal space. But we're here. So I'm going to ask some hard questions. I'm going to say some things that might sound a little controversial, but they're done on purpose to spur conversation. And there's none of these things that I'm super dogmatic about. And there's a really good out to any of these, which is, I'm not an IC maximalist. I want a multi-chain future. Okay, I'm going to talk a little bit about that, and you can disagree with me, and I would love for you to come and change my mind. We're all still learning, and this path, lots of paths are out in front of us. So, I'll start by talking about Attwod's law. I don't know if you guys have heard of this, but it's a thing in the JavaScript world where this guy Attwod said, any application that can be written in JavaScript eventually will be written in JavaScript. And this generally holds true. If you go to NPM today and you type in whatever your heart's desires, you will probably find a TypeScript or a JavaScript package that lets you do that thing. I have this law that I've sort of been banging around for 2 years that says that any sufficiently interesting consensus protocol that can be ported to the internet computer will be ported to the internet computer with sufficient security and equal or superior scalability. So what does that look like? Let's go back to maybe not early days of Ethereum, but 2017, back when dApps really sort of started coming onto Ethereum. You had things like CryptoKitties. Totally jammed the network, right? People were paying massive gas fees to trade these cute little kitty cats. And it caused a lot of problems, and people quickly realized, hey, you can't do this on Ethereum. We need scalability of the Ethereum network, and that started very much in haste around that time. The ICs solved a lot of these problems with reverse gas. We can put assets on chain. We can host the dApps on chain. We really have an amazing platform that solves some of these early Ethereum problems. You look at things like Augur, which was a prediction market. Prediction markets don't work when your gas fees are out of sight. They muddy the cost of voting in these prediction markets. So we have apps on the IC like Sears that are trying to do some of this with reverse gas, and I think it's going to end up working much better. So the things we're doing on the IC here, there are other scalability layers. You've got Polygon, Solana, Optimism, all these things. But the reality is, the IC is faster, sometimes hundreds of times faster than those chains, those L2s. And I'll argue that the IC provides sufficient security. Certainly for a cartoon cat game, probably for a prediction market, likely for a lot, if not almost all enterprise applications that need to exist outside of apocalyptical scenarios. Then you have things like DeFi, same problems, gas fees, scalability. A swap doesn't work if you have to pay more in gas fees than you're swapping. We have TECDSA technology now. AstroX was talking about that and the amazing things they can do with their canister wallet. We have these smart peers where you only have to have a contract on the IC side and you can hold native assets. Infinity Swap, Sonic, IC Lighthouse, ICP Swap, Helix, these folks are all bringing these and making these a reality. And I think as much as DeFi stays a thing, I really think we're about to see some seriously interesting things happen in this space. L2s, people talk about optimism and ZK rollups. A lot of these L2s are very single-minded. You go to ETH Denver and you go to a booth and someone's like, I'm building an L1, or I'm building an L2 for X. It's like, okay, well, on the IC, you can do X and Y and Z, on and on and on, all on the same interoperable chain. So why would you settle for a subset of this functionality and then have the complexity of integrating with all the other chains just to put together a toolbox to achieve what you can achieve on the internet computer right out of the box? So IC solutions, they're Turing complete, they're faster than other solutions, and they're scoped to interoperability. They're just superior to single focus chains. And we need to be pushing these narratives. Now, there is one big trade-off, which is security. But I think there's there's the crypto-anarchist view of security, and then there's the reality of security. And the reality, especially in the enterprise world, is that they're all running on one doxed server. They're either on AWS, or they're on Azure, or they're on Google. Right? What the IC offers is this sort of 4 to 32 doxed node solution, which is I think better. I think you go to enterprise and you say, hey, you still have this protection of, you know, the nodes who are running the network, you know where your data is, and you have recourse, but you gain all these decentralized components like making scalability and data duplication and all of that kind of go away and not have to worry about them. And if you really look at the security of other chains, here we have Bitcoin and the breakdown by mining pools, and you only need 2 of these guys to collude to really cause some problems to the Bitcoin network. And if you look at the signature ring for Polygon, you count those slices, and you get pretty close to 11 to 13, which is what the IC has with 13 node subnets. So the reality of the security on the IC is that it is at least sufficient for most use cases. But you still have this sort of World War III scenario, right? And Ethereum 2, in their mission statement of designing ETH2, specifically said, hey, we want to build a network that can survive World War III. So if you need that, it's there, and that brings me to sort of my second law, which is IC Maximalism is ETH Maximalism. In this world, the Ethereum remains this settlement layer that provides that World War III security when you need it. There are some applications that need it. If you're a bank or a state or something like that, you probably need to have some of that security. But for the rest of us, for most consumer and enterprise applications, the IC is, right now, the place to run those. You have the most scalability. The L2s that provide sort of single use, some of them have network effects right now, but over time, network effects fade. And so I think this is still a world that can exist in the near future. Now, what about ZK tech? Because you hear a lot of the themes right now are that zero knowledge proofs are here to save the day. And ZK tech is just amazing, magical math, and it really has some awesome properties. But right now, ZK tech is hard. And it's also bad at data-rich applications. A lot of the places that you see it where it's really useful is for smaller calculations, things like ledger calculations, token calculations, but for data-rich stuff, not as useful. And it really needs more time to bake. When it gets baked, it's going to be amazing. What we have right now with the IC is we have an opportunity to go out to these other chains and people who are trying to basically push forward with ZK tech that's not quite ready for prime time and say, hey, the IC gives you 5, 7, 10 years of scalability that you didn't know you had, while you bake in and create high-level languages on top of ZK knowledge where you make it accessible to your average developer to be able to go in and build those. In addition, when ZK tech is ready, because we may have a breakthrough in 3 months where it just becomes a super easy thing to build with, when it does, the IC is a prime place to put that, because you have this data availability problem with ZK proofs where there is definitely zero knowledge and private stuff that doesn't have to go on chain, but there are also public inputs, and if you want to replay and replay those transactions and reprove those things, you need this data, and if it's just pinned on IPFS somewhere and it goes away, you lose some of that ability to analyze what's gone on in your chain. So when we do have ZK stuff ready to go, the IC is going to be an amazing tool in that toolbox for those who want to deploy zero-knowledge proofs to other chains. Now, this one might be a little controversial. I think that in an IC maximalist world, you reject 2023 Bitcoin as an unethical technology. And going forward, we need to focus on green tech without proof of work. There's no doubt that CKBTC as a technology on the IC, it's a totally logical thing to do, right? It's a proof point for TECDSA. And we have it now, and it's incredibly useful, and there's incredible value on the Bitcoin chain. But I also think that in an IC maximalist world, you move on. Now, I'll explain why. I understand that everyone has to make a buck. I understand that resources are tight. And I understand that right now, a lot of us just feel like we have to survive. And there's a lot of froth over in Bitcoin. But if you sort of, this concept here is Bentoism, which has been around the Web3 world a little bit, and it asks you to move beyond just simple self-interest and just the now me. What can I get now for what I have? And it asks you to move beyond that, to think about everybody else as well. And then to look forward to your future self and say, hey, when I'm old and wrinkly, what do I want the world to look like for me? And what do I want the world to look like for other people? And so what we're targeting is, we want green in all 4 of these quadrants. We want to build things and focus our attention in areas where we're all going to win. And the question I kind of want to ask is, does further Bitcoin integration get us where we want to go? And I'd argue that it doesn't. Do we want to sacrifice the future for today? Bitcoin is an amazing technology in 2011. In 2023, it's a climate catastrophe. Do we want to waste more time building more tech for something that's eventually going to set the world and the sky on fire with burning monkey pixels? I don't think that's a thing that we particularly want to do for our kids down the road. So how do we deal with this? Well, I think that in an IC maximalist world, we focus on the elimination of proof of work through technological innovations. CKBTC is a technology that implicitly does that, and it may even actively subvert those that are relying on proof of work. And I'll explain that now. And it's through this third law, which says, in the future, greater than 50% of circulating BTC and ETH will reside inside of IC canisters. I think this can actually be a thing if we're successful, and AstroX does what they're doing with their integrations, and the other groups that have been here and been talking about integrating with Ethereum and BTC. This is real. I mean, zero fee transactions, right? That's huge in the Web3 world, and they haven't woken up to that. So, but it creates a poison pill on both sides of the equation, right? To be fair, there's 2 sides to this. First of all, what happens in a world where most transactions occur on the IC with no transaction fee, and BTC relies on transaction fees for network security. Eventually, the halvings go away in Bitcoin, and all they're left with is transaction fees. If all of that's happening on the IC, how do they maintain security? On the other hand, we have this problem on the IC, that there can become so much value on individual subnets that collusion becomes inevitable. What happens when you have a bunch of $10 million value corporations running nodes that secure billions or trillions of dollars? So both sides of the equation here have the opportunity to solve this problem. But I kind of ask, how can BTC adapt to combat this? Can they move to a proof of stake or a solution that's not based on proof of work? The ideological velocity of the network has shown that they don't do a very good job of this. And do we want to bet that they can eventually figure it out? I'm not so sure. On our side, on the IC, we've shown the ability to adapt. I don't know if Jordan's in here, but Jordan is probably the biggest champion of keeping us honest about these things that I've seen out there. There are things that we can do to make our subnets more reliable on the internet computer, and I think we have the willingness, and we've talked to the engineers at Dfinity, and they're all working towards solving these problems. We can do node shuffling. We can put things inside of enclaves so that the node providers don't even know what's being processed. We can randomize those node assignments so it's harder to collude. We can also build pluralistic replicas, not just one replica, but other replicas written in TypeScript or Python or Motoko or whatever language, so that the nodes are actually running different replicas, and if you want to attack them, you have to write twice or 3 or 4 times as much code. We can also play a slashing game. We could have TECDSA providers actually have to post stake and play a slashing, backstabbing game where you have a lot to gain by backstabbing your co-node if they try to collude. And if you do that and everybody backstabs in every round, then we're all good. If a couple people try to collude and everybody backstabs, then they lose a lot of stake, which may not be great for the node providers to have to put up more capital, but I think we eventually get to a point where that has to happen. So the IC has options and a willingness to adapt. So where do we think we're going to end up? How is this poison pill going to play out? I don't particularly know the future, but I think it's something that we have to address and we have to look at. ETH is protected from this a bit more than BTC is, the poison pill, because they've already moved to proof of stake, and validators are paid on a percentage rather than transaction fees, so you can still maintain this sort of World War III level security at the settlement layer, even though transactions may go to 0 on the Ethereum chain, or very, very low. Fourth law. It's my very personal opinion. It's that Motoko is maximal. If you don't know what Motoko is a programming language that was designed for the internet computer. And now I'll be the first, since 2017, I kind of started sniping at Dfinity a little bit and saying, guys, how can you build an internet computer that doesn't speak the language of the internet, which is JavaScript? Why can't I write my smart contracts in JavaScript? This doesn't make any sense. We're leaving so much on the table. This law is that Motoko is maximal, but we love pluralism and lots of options. Once I started using Motoko, I kind of fell in love with it, and I waited way too long and was way too hard-headed. Here's why I think Motoko is maximal as a language to use on the internet computer, and why I think you should consider it. First of all, Motoko compiles to bare WASM, which has a cost and cycle capacity advantage over VM-based languages. Now, that can change, and I know that especially Jordan, who's done just amazing work at Demergent, getting JavaScript up and running and Python up and running, has been working with Dfinity to solve this problem and make it much more performant. But there's still just some advantages to being bare WASM, right? Motoko also has a straightforward and innovative type safety system, which is very important when you're doing smart contracts. It also lacks memory management. And if you want to talk about a poison pill for the development environment, it's memory management. As soon as you add memory management to your language, you lose like 75% of your potential audience, because there's some developers who are just going to bounce right off of it. A lot of developers. I think that the Maximal language is a high-level language, and in a lot of cases, this software has to be rewritten anyway. If you have existing libraries in Rust or C or JavaScript, as soon as you hit long-running processes, you hit this problem where the assumptions in your software are that they can run for infinity. And on the internet computer, you're bounded by, even with time slicing, you're bounded by a certain number of rounds. So for long-running software, we're going to have to rewrite a lot of that anyway. Why not do it in a language that is, last point, shaped like the internet computer? The IC is an actor-based system, and Motoko is designed as an actor-based language. Now, VM-based libraries are cool and absolutely necessary. When you look at pluralism and wanting to have diversity and being anti-fragile, you want pluralism. So again, Jordan's just done an amazing job in bringing 2 whole new languages to the table, which is just amazing to me. And even if they never solved the performance issues, and I think they will solve the performance issue, but even if they didn't, it's an amazing gateway drug for developers. All those JavaScript developers, all those Python developers, with Solidity, we're going to get the EVM, and Max at Bitfinity, they're bringing over the EVM finally. You talk about our highest affinity group, for 2 years hasn't been able to program for the internet computer, and in a couple months, they're going to be able to hit 2 keys on hard hat and deploy all their Solidity contracts to the IC. That's going to be huge. That's a gateway drug that gets them here, and if they do hit a performance bottleneck, they have the other language, the bare WASM languages, to fall back to, which I think is super important. That brings us to Rust. Rust is the first thing you hear when you talk to Rust devs is that they love it, right? It's a really powerful language, and it does a lot of things. It does a lot of things really well. And it's also currently dominant on the IC. But I do think it's been a bit limiting in our growth. And if you're deciding out there, hey, what should I do? I think you need to ask this question, and we've seen some of it out in crypto Twitter even this week. Who's going to read your code and audit it? Are consumers that need to approve it to get to the next level of funding going to be able to look at your code and know what's going on? I don't know how many of you have actually gone to look at the ledger code that's written in Rust. It is not easy. If you take that and you go look at an ERC20 contract written in Solidity, there's an amazing difference in grokkability between the two. So especially if your code is going to be open sourced and you're going to ask people to give you money based off of its ability to do what it says it does, if you need Rust and there's an absolute reason you have to have it, go for it, right? But if you might need the world to see your code and see what's happening, maybe look at one of the higher level languages, especially if you don't need that just amazing performance. Fifth law here, the IC is an authenticity machine. This goes into some of our work at Origyn, where we believe that massive compute and massive storage are going to be ubiquitous and required for authenticity checks. We're about to go into a presidential election in the US, and I know that extends to the world to some extent. I don't know, for whatever reason they pay attention to it. It's going to be a disaster. The amount of misinformation that's going to be produced by AI in the next 2 years nobody knows what's going to happen, right? How do we authenticate digital media, especially? How do we overcome that difficulty and verify the authenticity of digital content? We need a reliable method to establish provenance. I think the internet computer can help us here. One of these pictures won second place in a photo competition for brands. It was like second place of brand picture. The other one was produced by a Midjourney, this Midjourney prompt in about 15 seconds. Which is which? Does it matter? Maybe not in this case, but if you're entering an art contest that's supposed to judge art that was produced by humans, it might make a difference. So we have this tech that we're working on called Mint at Secure Source. And basically, everybody's phone has this enclave in it that has a private key in it. It's what you use to log on to your internet identity. And what we're looking at doing is actually trying to work with OEMs to say, hey, as soon as the data comes off of your sensor, whether that be your video sensor, your audio sensor, whatever, let's take a pre-mint of that. We're going to take a hash, we're going to put it on the internet computer. Now, what this means is, at Origyn, one of the things we want to do is take data from every picture that's written, or every picture that's taken on every device in the world, and have it written to the internet computer. It's a big scalability problem, right? But that's something that we think is actually possible, and the IC is the only chain that's even hinting that it might have that kind of scalability. Once this pre-mint's out there, we just let them sit there. When you want to output your media and put it onto social media or whatever, you can mint it to an Origyn NFT. You get all these amazing cool features that the Origyn NFT gives you, like an instant marketplace, DApp storage, third-party access, all of the augmentation tools that we've built into the internet computer, into the Origyn NFT. You get all that for free, and now you have a signature, a private signature that will let you say, hey, not only was this definitely taken with this kind of device, but it was also taken by this person, and you know that it was an authentic image. Now, the next problem after that is almost every piece of media, even on your phone, before you see it, is run through AI or run through filters or run through cleaning mechanisms. If you change one pixel on an image, the hash changes. So how are you going to track this stuff? Manipulations, they amplify this problem, and what we want is a clear chain of title, and blockchains let us do this. So the second tech is called SECT. It's stands for Secure Transform. What this allows us to do is mirror computation on chain. You don't have to run it on chain. You just need the computation to be deterministic, and then your Adobe software or whatever software you're running, every change you make, every pixel you change, all of those get logged and pushed onto your Origyn NFT. And when you create a derivative NFT, all of that is referenced. And you now not only have a chain of title for the manipulations, but if any filters were run, you can attribute that to the programmers who built those filters. If AI was run, you can attribute it to that AI, and people can actually get a seal, on their newspaper that says, hey, this thing was manipulated, but it was manipulated by known protocols and not any that falsify and fix things, and you could actually see that chain of title. And if that media gets monetized, we have a chain of title where we can attribute all the way back to Genesis across the media attribution and reward those people. If someone lies, there's a verifier network that can slash the originator of the image for lying on the system. They can actually run those transforms on chain when needed. So what's next? How do we get to this IC maximalist world? First is enterprise adoption. This is how we hockey stick. I don't think it's a consumer application. I think it's going to be enterprise. And two things have to happen for enterprise. The first one is encryption. We have to know that data that's on the node is not accessible by the node providers. Definity has three ways they're attacking this. The first is with SEV enclaves on chain. That's probably a little further out. They have this vet key tech that's coming, which is very intriguing. That doesn't let you compute over the data on chain, but it does at least get you that storage on chain in a secure way with a key that the nodes can't reconstitute without colluding. And then there's also Zama, which is a multi-party compute. I think that's definitely out in the future. The second one is node selection. Enterprises are under regulation. There's things like HIPAA and GDPR, which say you can only keep your data in certain geographies, and it's kind of senseless in a digital world, but that's what they say, and the enterprises have to comply. So we have to be able to give them assurances that, hey, if you put this data on this node, it's not going out of the EU. Here's an action item to help us get to an IC maximalist world. Go port a protocol. What's everybody talking about on Ethereum? What's everybody building on? Go grab one, go write it in Motoko or Rust and deploy it to the internet computer. Duplicate Gitcoin. Luxo is this entire L1 that basically does what internet identity does. And in fact, I think AsterX was talking about the account abstraction, right? Like, we have all the tools to do account abstraction in a much better way on the internet computer without having to build an entirely new L1. So go do that and show the world that it's 100 times as fast and that it has sufficient security. When you talk back to the EVM, like the Ethereum EVM, it won't know. You're signing with ECDSA. It doesn't know if you're an L2 or if you're the IC. It just knows that you're working, right? I think we need to build utilities and not dApps for a while. This one also may be controversial. I know that there's been a huge push for dApps. Here's a problem. Decentralized architecture resists value capture. It's built to get middlemen out of the way. If you're building a dApp and you look at the economic model of that dApp and it has value capture in it, you have to understand that the protocol you're building on resists value capture, and it moves the value to the edges of the network. Now, will people pay some premium to utilize it? Maybe. But as soon as you get it out there, somebody's going to be attacking you. So what do you do here? Because especially if you're trying to get funding, VCs like to make money. You want to get their money, right? So there's a way to build utilities, and it's what we're doing at Origyn, where you really look at the platform and you have to move beyond governance. Governance is one utility, but when you build these applications, you have to find a way to use your token for more than that. Examples in Origyn, we're trying to think of new ones every day, but right off the bat, we mint new certificates, we burn OGY. We have a price discovery mechanism that requires you to lock OGY in the same way that you kind of stake for governance. And it builds on top of each other. You're locking your price discovery also gets you voting rights. So these utility stakes can kind of stack on top of each other. We have our perpetual OS registry, which has a mixture of burning and locking that'll be coming out soon. So I think you can still build amazing, profitable utilities that kind of raise all boats, if you will. And I think we need to look at doing some of those. And it's not a hard turn to take your dApp and convert it more into a utility mindset. It doesn't make as much sense to the market initially, but if you can get over that hump, I think there's actually way more value. And then we need code infrastructure, right? I think right now every dApp that I talk to, every protocol I talk to on the internet computer, everybody's building the same thing. They all run the same problem, and they have to go and build an event system, or they have to go build a queue, or they have to go build something to interact offline with the off-chain stuff. So really investing in the code infrastructure, we still have a couple years of that where we can get to a level where we're competing with Web 2 developers who can just run because they type npm this and it just works, right? So for the IC, we've got to build those out. EVM on the IC, I think we're getting that soon, which is amazing. Motoko to Rust bindings. We've been talking to the IC guys, the Dfinity guys, about at least getting this basic functionality in that will let Motoko use external compute from things like Rust or C, which would vastly make Motoko more useful. And then ultimately all the tools that make shared data spaces a reality, where enterprise can co-locate their data with their competitors and their suppliers, and it's private, and yet we can compute over it and do audits against the data that both sides will trust without having to pay millions and millions of dollars for accountants. So, I do Origyn, I also do IC Devs. You can donate to IC Devs, and we are trying to build these tools. If we don't get to an IC maximalist world, it's going to be a multi-chain world. We got to build all the same tools anyway. We need them on the IC to be a competent player. So again, these are highly opinionated, lightly held opinions. Come talk to me. Change my mind on these. I only have one perspective, and it's a perspective that I've been pursuing. And now that we're all here in person, I want to hear y'all's inputs on that can help change my perspective, and so that we can help build better software for everybody together. So thanks for entertaining me and my crazy ideas, and I'm looking forward to talking to you all.
The highly opinionated Austin Father, everybody. Thank you so much.